In this screencast, I'm going to demonstrate an OpenGL game written in C++ running in a web browser using the Flash player. The game that I'm going to demonstrate is called Neverball. Here I have it installed natively on this Windows 7 machine. If I launch it, we can see that we can click play, choose a level, and the point of the game is to use your mouse or your keyboard to rotate the level and tilt the map so that you can roll the ball around and collect coins. Once you've collected enough coins, you can head to the red and white exit circles over there and move on to the next level. I'll just pause that. This is a pretty fun game. It's pretty challenging, but it's also really cool because it's open source. And so if you want to learn how to make a game like this, it's easy for you to look at the code and see how things were implemented. So now I'm going to demonstrate that you can take a game like this, written completely in C++, and compile it to run in a web browser using the Flash player. The tool we use to do this is called the Flash C++ compiler from Adobe, also known as Flask. Flask is an SDK that allows you to compile portable C and C++ code into a Swift that can run anywhere the Flash player runs. To learn how to compile Neverball into a Swift, check out this article on the Adobe Developer Center by Alex McDonald. The Flask engineering team at Adobe have already ported this code and have hosted the Swift online for anyone to check out for themselves at cmodule.org/Neverball. So now let's see an example of this game running in the browser. I'm going to fire up Google Chrome and I'm going to go to cmodule.org/Neverball. Here the Swift is loading. Once it's done loading, you see the same starting menu. We're going to click play. Here we'll choose a name. Click easy. Let's go to that same level. Again, you can use your mouse or your keyboard to tilt or rotate the map, collect some coins. It's the same gameplay as our native desktop application. Okay, let's pause that. Now just to demonstrate that I'm not tricking you and this is actually Flash, I'm going to launch Adobe Scout. Now Adobe Scout is the next generation Flash profiler that allows you to really get a ton of information about a Flash program that's running and figure out how to optimize it based on the memory it's using and the different actions going on in each frame. So here I've launched Adobe Scout. Let me just move this off to the side and let's launch Chrome again. And again, go to cmodule.org/Neverball. And shortly, once this Swift starts up, you'll start seeing Scout recording performance information that it's seeing. And here, each of these columns here represents a frame. And you can see that as this Swift is playing, we're recording a bunch of new frames. So that looks like enough information. Let's close the Swift. And there we go, the data stream stops. So here we can go to all the different frames that have happened in this game. And for example, we can click on one here, let's say this one. And we can see that here we had 28 frames per second, which is not bad, but we could do probably a bit better. And here we can see that this frame, 10 milliseconds, was used up in ActionScript. And if we wanted to, we could really dig down into which ActionScript function was being called and which used all the time. So here the enter frame handler is obviously taking all of the time, and dig down into figuring out, okay, which function can I look at optimizing and what benefit will that give me? So for example, maybe I want to improve my game draw function or my soul back function. There's a ton of information here, including memory and GPU memory, events, all sorts of stuff that I'm not going to go into in this demonstration, but definitely check it out online if you haven't already. Now I'm going to close Scout, and of course Flask generates a Swift file which runs anywhere the Flash player runs. And that's awesome because we can run this in another browser. Here's Firefox. And we have the exact same Swift, the exact same gameplay without having to do any additional implementation or any additional testing to support this browser. Here we go, exact same gameplay. And just to prove a point, I'm also going to try it in Opera. So we've tried Chrome, we've tried Firefox, here we'll try Opera. And again, it's the same Swift, it's the same code, no additional testing, no additional implementation. Now you can imagine doing this using JavaScript and HTML, using the WebGL specification to get GPU accelerated graphics. Now, unfortunately, Internet Explorer does not currently support WebGL. And so if you want your users who use Internet Explorer to be able to see your content, you're not going to be able to use WebGL. But luckily, Internet Explorer supports Flash, and Flash supports the Stage 3D GPU accelerated graphical APIs. And again, in Internet Explorer, we can play just like any other browser without any additional work. And the same goes for the same browsers on Mac as well as Safari. So there's an example of porting a game written in C++ being deployed to the browser to reach a new, potentially vast customer base. If you would like to port your C++ or OpenGL game, then be sure to check out Flask. Here are some resources to get you started.